New DevOps project. So we are deploying a 3-tier complex cloud native application on Kubernetes. This application has React as a frontend, Golang as an API, and MongoDB as a database. Let me explain you how this project works. So you can see the application has been deployed here, and I'm accessing this application through a service endpoint, which is a load balancer type. So this is my load balancer's DNS. Now this application is a voting application with frontend created in React and JavaScript, but we will be using a Docker image to deploy this. So the idea is whenever a user comes here and votes for the programming language, the data should be taken here and should be updated in the MongoDB database. So as you can see here, Python has 1 vote, whereas Node.js has 8 votes, Java has 9 votes. So you can see the same here as well. So Node.js has 8 votes, whereas Java has 9 votes. Let me show you this live. So I'm going to add some more votes to Node.js. So let's make it more. So now I have 10 votes for Node.js, and for Java I'll make it more as well. So now Java has 13 votes. I can add more votes to Python or any other language. So it's just that the user is going to add some votes, and whenever user adds some votes, the data should be fetched from Golang API and should be updated in the MongoDB database that we have here. So this command is to run the command inside this particular pod to query the langdb database and show us whatever data we have. Once I run this, it will show me the updated votes, which is 10 votes for Node.js, Java 13, 6 for Golang. Now this application has multiple things, like it has 3 pods for MongoDB database, 2 for API, 2 for frontend. It has a service for API, frontend, and Mongo. Also 2 deployments, replica sets, and 1 stateful set. To explain you this, let me show you the architecture now. Our architecture diagram, as you can see here, the application is going to be deployed on Kubernetes. So we will be using Amazon EKS to deploy our application. So in this application, we have 3 things: frontend, API, and MongoDB. We will start with creating MongoDB. So the MongoDB have 3 pods, pod 0, pod 1, and pod 2. And they are going to be deployed using Statefulset. So why do we have 3 pods here? We have 3 pods to enable replica sets in MongoDB, where the first pod is going to be primary, that will read and write data, whereas pod 1 and pod 2 are going to be secondary, which are going to be having replicas of the data, but will only work when the first pod is deleted or destroyed. So as you can see here, we have replica set enabled for the first pod being primary, second secondary, and third secondary as well. Along with the pods, we also have PV, also known as persistent volumes, and persistent volume claims to store the data from the database into EBS volumes in AWS. So we will be creating EBS volumes as well. Second, we have API. So the API is going to be deployed using deployments, and we will have 2 pods of API. This API is created in Golang and exposed using a service of load balancer type. So to show you that in action, I have my API here. As you can see, this API is fetched, and we are using a path /OK. If I try to query some languages path, you'll see these are all the languages. I can also query particular language, which is here, which will show me all the votes. And then this data is going to be then fetched into the MongoDB database, where we will see all the data properly. So how do the API get the data? The data is going to be get from the front end. So we are going to be deploying front end using deployments. We will have 2 pods of front end. The front end is in React, as you already know, and it is going to be exposed to a service of load balancer type, and that's what our application is. Now it might sound complex, or it might be complex for you, but trust me, it's going to be very, very, very interesting learning for you. And if you want to learn Kubernetes the practical way, I would highly recommend you checking and doing this project. Along with this, you will also learn many MongoDB concepts like replica sets and different queries. So please do this project. If by any chance you are facing issues or you are stuck in this project, feel free to use documentation and many online resources. But if you're still stuck, let me know in the comment section. I'm going to help you. I'm going to help and reply on all the comments. And if you've successfully completed this project, please share it on LinkedIn, and don't forget to tag me as well. I want to see how many of you can actually complete this project. Let's start. Alright, now that you understand what is this application and what are we going to create in this DevOps project, let's start with actually creating it. So I'm here on my AWS dashboard, and I'm logged into my account using an IAM user named as Nasi. So we are creating this application on Kubernetes, and we will be using Elastic Kubernetes Service, which is Amazon EKS. And along with this, we'll also be using load balancers, EC2 instances, EBS volumes for persistent volumes. So before we move ahead, just to let you know, if you are doing this project along with me, you're going to get some charge of around $2 or $3 at max if you're running this application. But despite the charge, I would highly recommend you to please do this hands-on project with me, because if you just watch the video, it will not make sense and you will not be able to grasp all the knowledge, because we are going to learn how to create deployments, statefulset, persistent volumes, namespaces, so much more, along with MongoDB queries. So I want you to please do hands-on and complete this project along with me. So saying that, let's go ahead and create our Kubernetes cluster. So I'm going to go to Amazon EKS service and let's click on create cluster option here. I'm going to give the name as cluster 1. For Kubernetes version, I'm going to keep the default version, which is 1.27, and the cluster service role is my Amazon EKS cluster role. Most of you had a question in the previous project that what is this cluster role and what permissions do you have. To show you, I have this role here, and this role has Amazon EKS cluster policy. So if you don't have this role by default, you can create a role and add this policy to it. Next, I'm going to click on next button here, and the VPC is going to be default VPC. I'm choosing the 4 subnets that are there already, and the security group is going to be default as well. Okay, now for endpoint access, I'm going to keep it public. For logging, I'm not going to enable logging because we don't need that for this project. For EKS add-ons, we are going to choose the default one, but along with this, we also need EBS CSI add-on, which we are going to add very soon because we need to create volumes for our MongoDB databases or pods. So once I do this, I can review everything and click on create option. Creating a cluster can take up to like 5 to 10 minutes. So till the time it is going to create, let's go ahead and add the add-ons here. So I'll click on get more add-ons option and search for EBS, which you see here, the EBS CSI driver. This is responsible for creating persistent volumes or EBS volumes automatically, and you need this for this project. So I'm going to select this and scroll down to click on next, click on next again, and click on create option. Alright, so this add-on will be also added in our cluster. Once this is created, we can go ahead and click on compute to add node groups. We are going to use 2 nodes of T2 medium instances, so we will add that only when the cluster is created. So till the time the cluster is created, we can go ahead and set up our other things. For this project, I am going to do this project on EC2 because most of you had questions or issues in the previous projects. You said, I have Mac, I have Windows, please do this project on Windows, please do this project on Windows or Mac. So to help you out with this, we are going to do this project on EC2. So no matter what operating system you have, you can still complete this project with me. So for this project, I'm going to create a T2 micro instance, and we will be installing Kubectl and all the other things on that particular instance. So I'm going to click on launch instance option here, and let's name the instance as project server. I'm choosing Amazon Linux for this. Instance type is T2 micro. Key pair is going to be US West. You can choose any key pair, or you can create a new key pair if you don't have any. For security group, I'm going to allow SSH traffic only, and in advanced sections, I need to add a role which should have access to my cluster so I can work with it. But using role will be a problem, like you can get a problem, and I'll show you how to troubleshoot that. So I'm using EKS role to show you what access or what permission do I have in this role. I'm going to search my EKS access role, which is this, and inside this I have this EKS access policy, which have these permissions. So you can create or copy this JSON and create a policy which have describe cluster, list cluster, describe node groups, list node group, list update, and access Kubernetes API permissions. Once you do that, you can attach this to your instance and go ahead and click on launch instance option. So now this instance is going to be created, and we can use this instance to actually manage or deploy our application. So for you to deploy or manage your Kubernetes cluster, you need to have a tool named as Kubectl. So this is a tool which we use to manage our Kubernetes cluster, and I have it in my local machine, but you will also need to use it or install it if you are doing it on EC2 along with me. So let's wait for this instance to come up in running state, and then we can go ahead and install kubectl in this instance. So now, as you can see, the instance is in running state. So I'm going to click on connect option here and click on connect again. Now to install kubectl, you can use the internet, but I have the commands already here. So I'm going to use the commands that I have. So once the instance is ready, we can go ahead and install kubectl here. Okay, so now the instance is ready. I'm going to clear the screen, and if I run kubectl now, it will tell me kubectl command not found because we don't have it. So I'm going to run this command, which is to curl the command to install to get the file from this particular bucket, and then change the permission, all the things to install kubectl in our machine. So this command will be present in the readme section. I have this GitHub repository created for all the manifest, and the readme is going to be updated very soon. For now, you can see the kubectl has been installed, and to confirm I can do kubectl command. So it will not show me errors similar to this. It will in fact show me all the different parameters. You can see version here, so I can do kubectl version command, and it will then show me the version, which means it is installed successfully. Along with kubectl, we also need to have AWScli, which is a command line tool to manage AWS services. In our case, it is Kubernetes EKS. So we need to install AWScli as well. And to do that, you can go to official documentation. So you can say AWScli download, and it will open up this. So we are using Linux instance, so we need to follow this doc for Linux. And I'm going to copy these commands, run them in my instance. So copy and paste, and it will start installing AWScli for me. Okay, so now we have kubectl installed, and we also have AWScli installed. So we will be waiting for this cluster to be in running state, so we can go ahead and add nodes. We require nodes because the pods are in the nodes, and if you don't have nodes, your pods will not be up. So we will wait for this to come in active state, and then we can go ahead and add node groups. Till the time it is still in creating state, I can clone this repository and then get the manifest file in my instance itself. So if you don't want to do it on instance, you can also do it on your terminal or on your local machine. If you have Linux, or if you have macOS, or if you have WSL in Windows, you can still try to do this on your local machine. It will work fine, even though you will get an error when you do it through EC2 instance. I'll show you how to troubleshoot that. But as most of you had complaints earlier, so I'm doing this on EC2 just to make sure that you complete this project along with me. And if you're just watching this video not doing it actually, I would ask you to please do it, because this is going to be very, very helpful for you to learn Kubernetes hands-on. So now the AWScli is also installed. I'm going to clone my repo here. So when I run git clone and paste the command, paste my repository URL, it says git not found, which means git is not installed. So let's install that as well. So I'll say sudo yum install git -y, and this will install git for me. Okay, so once the git is installed, I can run the same command again, and then it should clone the repo for me. So you can see now my repo is here. I can go inside it, and I can go inside the manifest section, and when I do ls, I can see all the manifest file here. I'm going to explain you this manifest file throughout the video, so don't worry about it. Let's see if our cluster is actually ready or not. Okay, now it is active. As you can see here, we have our cluster is active. Let's go ahead and add a node group. So I'm going to say add node group button here, and type ng, or I can say node group. For node group, I have a role which is my Amazon EKS node role. Again, if you don't have it, you can check the node, check the permission that I have in this, and you can also create it by default. So this is the role, and I have these 4 permissions in it. So if you don't have it, pause the video and create a role, and then you can attach that to your node group. Next, I'm going to click on next without selecting anything. And for AMI type, I'm using Amazon Linux. Capacity is on demand. For instance type, I'll be using T2 medium. So I'll search for T2 and then select this. For disk size, I'm keeping 20. For desired size, it is going to be 2, which means 2 nodes of my instance of my Amazon Linux will be running all the time. And then click on next again. For subnet, I'm choosing the default subnets in my default VPC. Click on next and click on create button here. So this will start creating the nodes for me. Now if you want to work in this particular cluster, how will AWS know? Like if you try to do kubectl get pods, even though if you don't have any pods or nodes ready, if I try to run this command, it will give me an error saying try this connection to the server was refused. Or even if I try to do this in my local machine by running kubectl get pods, it will give me an error saying unable to connect to the server, dial this. So we need to first set the context and then we can actually use it. So if I run, to set the context, I need to run this command, which is AWS EKS update -cube config -- name of the cluster, which is cluster 1, and the region in which you have deployed it. So US-West-2, because I'm using Oregon region. Once I press enter, it will show me that the context has been added. And now once everything is ready, it should also show me when I run the kubectl get nodes command. So in the compute section, you can see this is still creating. We have to wait for it to be created, and we will then see 2 instances in our EC2 section as well. So right now you can see there's only 1 instance. We will, once the node group is ready, we will then have 2 instances, which are the 2 nodes going to be created as well. So I'm going to pause the video for now and come back again when my node group is ready. Alright, so now the node group is active with 2 nodes, as you can see here. And if I try to run kubectl get nodes in my EC2 instance, which is launched and is accessing my EKS cluster through the role. So this instance is accessing my cluster through EKS access role. When I try to run kubectl get nodes, it should show me that 2 nodes are created along with the DNS. But if you see here, it says you must be logged into the server. Whereas if I do the same thing in my terminal here, let me clear the screen and set the context. Okay, I'll set the context by saying AWS EKS update -cube config -- name cluster 1 -- region US-West-2. Okay, now I've set the context here, and if I try to run kubectl get nodes commands, I will get the nodes as you can see here. But when I do the same thing here, it's not giving me the nodes output. This is because, so I'm getting this output only because I'm logged in due to the keys of this particular user, which is the creator of the cluster. Whereas this instance is getting this error because it is accessing cluster not through this particular user, but through an IAM role, which is EKS access. So in AWS, you will get this error unless you give permission to the role so that it can access our cluster. And how can I do that? I can do that by editing the config map. So if you don't know what is config map, feel free to go through the official documentation to understand what is config map, and you can read about it. But if you want to see how I can edit it, let me show you. So I'll run the command kubectl edit config map, and you need to edit the config map, which is AWS-auth. This is the name, and it is inside the kube system namespace. So when I run this, it will open a VI editor with this file, which is a config map, and I need to go till the kind, press I to go to insert mode, and then I need to start typing some configurations which should be exactly below this group. So I'll go down and press dash and type in these things. So the role ARN, where I need to put the ARN of the role that is used to access the cluster, and this is totally optional for you. If you think this is confusing, feel free to put your keys directly by running the AWS configure command. You can run the AWS configure command and put the keys of the user that created the cluster, but most of you in the comments will tell me that this is not a good practice, which is actually not a good practice. So I will show you how you can edit config maps and give access to different users or roles in your AWS. And if you don't know how to do it, you can also follow this particular documentation by AWS, and there's also a video by this person. So if I scroll down and show you, you will see the command that I ran right now, which is the edit configmap command. So let me search for it, edit config, and you can see this is the command. Once you edit it, you can give access to different IAM users or different role as well. For us it is roles, so we will be using this section. So I'm going to add ARN for my role, and which is here, so I'll copy it and paste it in this. After role, I need to add the username. So as you can see here, it says username, which is the name of the role. So I'll say user name, and the name of the role is EKS access. Next, I need to define the groups. So I'll be putting this the groups here, and it should be inside system masters. So I'll say system masters. Now I'll press escape WQ to save this file. Once I do this and everything is fine, it should give me configmap auth edited. If you get any error, make sure that the indentation and everything is correct. Next, if I go back now and try to run the same command which gave me error earlier by saying, so let me stop this first. I'll say kubectl get nodes, and this time it will not give me error because now my role has access to the cluster. This is how you can edit config maps to give access to different users, and whenever you get this issue, you should always go and check that the config map has the rule added or not. This can also be an error when your nodes are not ready, so make sure you see that the nodes are ready as well. Okay, now everything is fine. Let's go ahead and deploy our application. We will start with creating the MongoDB. So we are using Statefulset to deploy our MongoDB pods, all the manifest file here. So let me explain you what is there in this Mongo statefulset.yaml. So this is the manifest file for Statefulset. You can see the client kind is Statefulset. Name of this Statefulset is Mongo. We are defining this in CloudChamp namespace, and just to let you know, we don't have this namespace as of now. So if I do kubectl get ns, you can see that there are all default namespaces. We need to create a CloudChamp namespace or else we will get an error. So I'll say kubectl create ns CloudChamp. Okay, this will create a namespace named as CloudChamp, and you can check that by running the kubectl get ns. Now you see CloudChamp active created 5 seconds ago. Okay, so this will be created in this namespace, and it is going to have 3 replicas, which means 3 pods running for Mongo. It has these labels and it has some affinity rules here. Now we are using container image as Mongo 4.2, and after the container is created, it will run the command, in this command, which is to start Mongo service or Mongo database. The port is 27017, and it is also going to create persistent storage, which is going to create EBS volumes of GP2 type. You can see here. So once we run this along with the pods, it will also create EBS volumes. As of now, if I show you, these are the 2 nodes we have. Let's name this as node 1 and node 2. So this node has a storage of 20 GB now, but once I run the statefulset, it will have additional 1 GB storage according to the stateful set manifest that we have here. So let's go and apply this to create 3 pods and PVC as well. So if I show you right now, kubectl get all -n CloudChamp has no resource. It should have no resource because we haven't created anything. Again, if I do kubectl get pv-n CloudChamp, it will tell me no resources found. But when I apply this particular manifest file, it will create 3 pods and 3 volumes along with PVCs or persistent volume claims to actually use it in our pods. So let's clear it and run the command kubectl apply -f, name of the file, which is Mongo stateful. Now when I run this, it will tell me that the statefulset.apps Mongo created, and when I run this kubectl get pods -n CloudChamp, you should be able to see the 3 pods very soon. So let's run this in watch mode, which will show us the pods creating. Again, if I come back here, and now you are already sure that this is 20 GB, but it should have additional storage now. So let's click on this and click on storage. You can see a new storage has been added here, and similarly for node 1 you will have new storage added as well. Okay, coming back here, you can see the instance now is in running state. So Mongo 1 is in running state, Mongo 0 is also in running state, and Mongo 2 is in container creating state, which will take like 1 second to come back again. Okay, so if I show you everything inside our CloudChamp namespace, we have kubectl get all -n CloudChamp. Putting this -n CloudChamp is very irritating, so let's set the CloudChamp as default. But you can see we have 3 pods ready, one Statefulset which created this pod, and we also have our volumes added. You can check that by running kubectl get pv or persistent volumes completely if you want to add that. So you can see 3 volumes are there, and you can also check pvc which are bounded pvc-n CloudChamp, and you can see 3 PVs which are bounded to this particular persistent volumes, which is exactly what we want. Now let's go ahead and do some configuration to set replicas. What do I mean by replicas? So if I show you, there are 3 pods in our for our MongoDB. So the Mongo 1 should be the primary database, whereas this 2 should be secondary as a backup if anything is wrong with this. And so to do that exactly, I need to first expose this MongoDB pods. And how can I expose this? To expose, you need to use service. So what are services in Kubernetes? You can read that in official documentation. So service is a method for exposing a network application that is running on one or more pod. And to expose this, we are going to use a service which is Headless service. What do you mean by Headless? In Headless, you have cluster IP and the IP set to none. And let me show you that in the manifest that I have here. So when I do ls, you can see this is a manifest. If I do cat mongo service .yaml, we are creating a service named as Mongo in CloudChamp, and this is the labels. It is running on port 2707. This is the target port, and the cluster IP set to none, which is a headless service, which means we are creating a service but not actually exposing it to the internet world. It is going to be exposed to this API, which will get the words from here and store inside the database, which is on MongoDB. Okay, let's go ahead and apply that by saying kubectl apply -f and mongo service.yaml. When I do this, it should show me service mongo created. And to confirm, you can do kubectl get svc -n CloudChamp. Okay, now you can see the service has been created, which is a Mongo service. Cluster IP is the type, and it is set to none. Now everything is done. Just to avoid using -n CloudChamp all the time, I am going to set CloudChamp as default. So I'll say kubectl config set -context -current -namespace as CloudChamp. Okay, so this will set CloudChamp as a default namespace, and if I do kubectl get pods now, it should show me the pods in the CloudChamp namespace only. Okay, now everything is done. We have our pods ready. We also have our service ready, and all we need to do is to set the replication so that this Mongo is the primary one, this is the secondary, and this is secondary. Once we do that, then we will load the data about the languages in our database, Mongo database. So if you haven't used MongoDB earlier, I would recommend you checking it out because it is very popular NoSQL database, and I use it a lot in many of my projects. So you can go to the official documentation to learn about more of it. Now, once I created this service, I can go ahead and set the replication as I said. So we need to use the command kubectl exec to go inside this particular container and run the commands. So kubectl exec -it and the name of the pod, which is mongo-0, and I want to also open Mongo shell. So I'll say mongo by -mongo. This will open up Mongo shell for me, which you can see here, and then I'll run some commands to set the replication with this being primary, secondary. So I have the commands already there, and I'll copy it. If you if I try to explain it, it will take more time. So rather than me explaining it, you can just go ahead to ChatGPT and paste the command. So I can say explain these to me, and then it can explain you in very simple manner. If you're not satisfied, you can ask him to make it more simpler, and this will explain you all the commands line by line. So this is just nothing but just to set Mongo 1 as the Mongo 0 as primary, and Mongo 2 and 1 as secondary replicas. So when I run this by copying it and pressing enter, okay. So now once this is executed, we can check the status, and it should show us that so I'll say rs dot status, and this, it should show me that the first one, which is the Mongo 0, coming back to the top, this is okay, yeah, this is Mongo 0, which is primary now, and Mongo 1 is secondary, Mongo 2 is secondary as well. Alright, so this is what exactly we want, and now we are fine. Now we can go ahead and add our data or insert our data in this database. So first we need to create a database, and I can run this command, which is use langdb. This is the query or a command to create database in MongoDB. If you are not sure, you can feel free to use the official documentation, and here you will see all the different commands and queries on how to create the database and how to insert something. So as you see here, there are insert methods, and this is the method, which is db.collection.insert. So I'm going to use that method to insert some data. When I run this, it will say that a database has been created, and we are also using that database now. So switch to langdb, and now I have all the queries here. So if I show you here, this query is to insert a data, which is all this. So name is C#, use case is this, and as a result it says write result. Similarly, I'll go ahead and do that for all the different programming languages that I have. So you can get this in the readme section again. I'll be updating it very, very soon before I upload this video. So once I do this, you will see all the results it says, and to confirm, you can run a command which is db.languages, which is the collection name, .find, and this. So when I run this, it will show me all of the data that is inserted. You can also see it nicely by using pretty, and you can see them in human readable format. So now, right now the votes are 0, and we have to create a system or an API where whenever someone on the front end adds a vote, it should be taken from front end and deployed it in the MongoDB, and we need API for that. So we will be using an API, and we will be deploying an API through a deployment. So let's go ahead and deploy our API now that we have our MongoDB set properly. So I'll go ahead and exit from this particular Mongo shell and from this container. Okay, so we have MongoDB with 3 pods, a service, and volumes created. Let's go and deploy our API. So I have API service here, API deployment here, and to show you what is this deployment, it is going to create 3, it's going to create 2 replicas of API, and it will be using this particular image, which you can find on Docker Hub, and then it is going to have a connection string, some environment variables, which is connection string, username, and secret, but we haven't created any secret here. So we need to first create a secret that will hold login details, which is username and password for this MongoDB database. So I already have the manifest again, so let me show you. This is the manifest file for secret. Let's cat it to see what's inside it. So mongo secret.yaml is creating a secret with this name in this namespace, and this is the username. So you might be thinking, what is this username and what is this password? Actually, this is admin and this is password, but it is in base 64 format. So every secret that you create in Kubernetes will be in base 64, and to confirm that, let me decode it for you. So base 64 decode and paste this, and when you see this, it's admin. The username is admin. Similarly, if I decode this password and paste it here, decode, and you can see it's a password. So the username is admin, password is password. This is what we have in this. Let's go ahead and apply this to create a secret, because this secret is actually used in API deployment. If I try to run API deployment, it will give me an error because we haven't created a MongoDB secret. So I'll say kubectl apply -f and Mongo secret. Now most of you might be thinking I'm going too fast or I'm speaking too fast. I know I have received those comments, but I want you to please, if you are not comfortable with this speed, you have an option to reduce the speed to 0.5x or 0.25x. But I try to speak slow. This is my speed normally, so I'm so sorry for that. Now it says secret has been created and we are ready to deploy our API as well. So I'll say kubectl apply -f and API deployment.yaml. This should create 2 pods of API, and we should also see it in our namespace. So it says deployment.apps.api created. You can check that by running kubectl get pods, and this will show us 2 pods for API which are in running state. And if I see kubectl get all, it will also show you all the things that are created. So we have three pods for Mongo, 2 for API, 1 service for Mongo, 1 for deployment for API, Replicaset for API, and Statefulset for Mongo as well. So these are all the things that we have as of now. To actually test this API and to see if we are getting the responses or not, we need to expose this API by creating a service. And we are going to create a service which is going to be a load balancer service. So I already have the manifest again ready, which you can use. But whenever you use this manifest, make sure you are able to understand, and for that you can always refer the official documentation or ChatGPT to understand it. So here, this is the manifest file. It's a service and the name of the service is API. These are the labels. It is running on this port, this is the target port, and this is the type, which is load balancer. Which means when I create this service, it will create a load balancer in my EC2 dashboard. Right now I don't have any load balancers, but once I create this, it will automatically create a service of load balancer type and a load balancer here as well. So you can try either do kubectl apply -f to directly create a service from this manifest, or I can run this command, which is an imperative command according to Kubernetes. So something I use to speed up things. So I can do kubectl expose. I want to expose a deployment which is API, so I'll say kubectl expose deployment named as API, and with the service that should be named as API. It should be a type of load balancer, so I'll say type equals to load balancer with L capital B capital as well, and port is going to be 80, so it should work on port 80, and the target port should be 8080. So when I run this, it should go ahead and create a load balancer service for me. So now that I press enter, it says service API exposed, and you can confirm that by saying kubectl get svc. We should have 2 services now, one for Mongo, one for API. Awesome. So we have this API and it's a load balancer service, and you can see it has been created here. If I go to my load balancer section and refresh this, you should see a load balancer created here as well. Alright, so this load balancer is now created, and to test out if my API is running fine or not, I can run a curl command, but it might take some time for the load balancer to come up in active state, right? So till the time it is active, I can run a command. Let me explain you what this command is doing. So the command is going to store the value of this thing in this variable, which is API ELB public fqdn. Along with this, it is also going to run a command saying until nslookup, like until the load balancer is in active state, show this message, and once it is in active state, run this command. So I'll press enter and it will show me a message saying OK. To confirm this, you can copy and paste this in a new tab and /OK to see what response you get and the OK path. So it says OK, which is exactly what we want. Next, it can also show me other things, like if I try to say languages, it will, language or languages, what? And you can also check by copying this URL, which is the DNS name, into a new tab and adding an OK path at the end, which will give you a response as OK. Similarly, we can also check API calls for languages. So if I do languages, it should give me all this. Similarly, we can also choose to get for a certain language here, either C#, Java, or anything. So let's say languages / Python, and you can get the data for Python only, which means our API is working properly and we are ready to move ahead with the front end part now. So the API is done with 2 pods actually, and a service of a load balancer type. And now we are going to deploy our front end, which will have the React application, which can get votes from the users on the internet, and then the API will get it. So the users will put the vote on the website, API will fetch it and put the data in the Mongo DB. So when I check the Mongo DB, which is to get the data, now you can see the votes are 0, but if someone's votes for Node.js, the vote will be 1. Similarly for Java and other. This is how we are going to deploy it. So let's go ahead and create our front end as well. I'm going to clear our screen, and for front end we are going to use a deployment file. Again, I have the manifest file ready here, so you can check the front end deployment is here, and we have the front end service as well. To show you front service deployment again, let's run the cat frontend deployment.yaml, and it's a deployment file which has a kind is deployment. The name is frontend, namespace is CloudChamp. We are creating 2 replicas, means 2 pods are going to be created. This is the image, this is the name. We are using an environment variable which is API ELB FQDN. This is why I added my load balancer DNS in this. Along with this, we have liveness probe and readiness probe, which means we should which is all we have. If you don't understand what it is, feel free to use documentation, feel free to use the ChatGPT, as I've been repeating so many times. Let's go ahead and apply it by saying kubectl apply -f frontend deployment.yaml. This will create 2 pods for us and a deployment as well. So if I do kubectl get pods along with the tag, so I'll say I do this, I'll see 2 pods for API, 2 pods for frontend, which is right now in running but still not ready. And if I do kubectl get all, you will also see everything that is done till now along with deployments. So we have 2 deployments, one for API, one for frontend, and it has 2 pods which are now running state as well. So we have this application frontend ready, but if how can I access it? I cannot access it unless it is exposed using a service that we have seen so far. So similar to API, we also need to create a front-end service which is going to be a load balancer type. So I'll say kubectl expose front-end, and expose deployment, because we are going to deployment and the name of the deployment is front-end. So I'll say deployment front-end using a service that should be named as front-end again. So I'll say front-end. Type is going to be load balancer. So type is going to be load balancer with L capital B capital again, and port is going to be 80, and target port is going to be 8080. Target dashport equals to 8080. Okay, once I run this, it will create a service and the deployment will be exposed as well. Don't worry if you don't understand this, I also have a manifest ready, and this manifest is here. So if you cat it, you will see exactly what I did as of now. You can choose to apply it directly, or you can also run this command by copy and pasting it. Okay, now to confirm that the service has been created, I can say kubectl get svc, and this will show me the 3 services that we have. This is the one for load balancer, and if I copy and paste this, I should be seeing my application in the browser. So let me open a new tab and paste this. So I'll have to wait, because again this will take some time. So I have this command here which can notify us whenever it is ready. So we are saying put the load balancers DNS in this, and then run this ins lookup until it is ready. Until it is ready, you should give me this message. When it is ready, you should curl it and I should see the response. So now it says it is ready. It says 200. Okay, just echo it right in my terminal here. I say echo and the name of the variable which has my DNS. So I'm going to copy this endpoint which is my load balancers DNS and paste it in a new tab. Once I paste this, you can see the language application, the voting application ready, and we have all these different languages. Whenever you add some votes or whenever a user adds some votes, it will be stored inside the MongoDB database. Let's try to test it out. I'm going to add some votes here for JavaScript and for Python because I love Python. Similarly for Go, I'll add more votes for Go because Go is the trending programming language now. Okay, so we have 12 votes for Go, 3 for Python and 7 for JavaScript. And I'm going to query the MongoDB database now. So let's go inside the database by running kubectl exec -it, the name of the pod which is mongo-0, and I'll open the Mongo shell. So I'll say --mongo. Okay, this should take me inside the Mongo shell, and to check all the data inside it, I'll be running we have to first use langdb. So I'll say use langdb and I'll say db.languages.find, and it should then show me all the list. So if you see here, there are 9 votes. Or let me make it pretty here so we see it in good format. So .pretty. Okay, now you can see there are no votes for Node.js as we have did. There are no votes now. 0 votes for Java as well, but for Golang we have 10 votes as you can see. For JavaScript we have 6 votes as you can see here. Similarly for Python you have 9 votes. So if I try to add more votes, let's try to add votes for Node.js and for Java as well, and try to run the same query again, and this will show you that the votes have been updated. So this is our application. So this is our application project. I hope this was informative. We have created everything from scratch, starting from creating a statefulset for deploying MongoDB database on pods, then creating a service to expose the pod to our API. We have also created our API with 2 pods using deployments and exposed it using Loadbalancer Service. We tried querying we also tried to run the get queries on our API, which gave us all the different responses. Lastly, we deployed our React application using front-end deployment, having 2 replicas and exposed using load balancer. There we go. This is our application. I hope you have understood, and if you have any questions, feel free to let me know in the comment section. So to make things more interesting and very fast, I deployed this application using AWScli, the GitOps tools, and I also have a video created. If you like this video, and I'm aiming for around 2000 likes, not more. So 2000 likes. If this video has 2000 likes, I will create a video on how you can deploy the same application on AWScli. I hope this was informative. If you have any questions, any doubt, let me know in the comment section. And if you're new to my channel, please subscribe to CloudChamp. We are very, very, very close to 50,000 subscribers. Thank you so much for everything, for all the support and love. Thank you. Let's continue learning DevOps. I hope you have a good day. Thank you and bye.